Hello and welcome to this lecture where we'll go into a background into what the database is and different types of databases. So we'll go into data and what type of data that exists. For example, structured data, unstructured data, and semi-structured data. And different types of data requires different type of databases in order to store them. So without further ado, we'll go into the keynote. So a short background into what a database is and different types of databases. So before going to database, we need to know what data is. So here you can see a picture of types of data. We have geographical, cultural, scientific, financial, statistical, meteorological, natural, and transport. And there are a lot of more types of data. From Wikipedia, we have a quote here. So data are a collection of discrete or continuous values that convey information, describing the quantity, quality, fact, statistics, other basic units of meaning, or simply sequences of symbols that may be further interpreted formally. Okay, so you can see now this definition from Wikipedia. It consists of a lot of different things, but let's highlight some parts. Discrete or continuous values that convey information. So this is what we need to know in order to, so we know that we have data that it contains information, and it could be discrete values or continuous values. So then we need to store it somehow, right? So then the data, it can be categorized based on its structure. So different data have different structures. So we have structured data, and they are organized in defined schemas. For example, then we use relational database tables, for example. And we have spreadsheet, CSV, Excel, so you can see it's a structured data. So tabular data. And then we have semi-structured data, which is partially organized data that doesn't fit in relational tables. And example of this data are JSON data. You have key value pairs, and this does not really fit into a relational database table immediately. Instead, if you want to put it into a relational database, then you need to transform the data, right? Otherwise, you can store it in another way using for semi-structured data. There's a NoSQL for that. And then we have unstructured data. So this lacks predefined structure, making them difficult to process. And this type of data could be like image, and an image is basically a matrix of numbers for storing the pixel values. And also if you have image in colors, then you have RGB, so you have three-dimensional matrices or tensor. And also you have probably an alpha channel as well. So basically it's a number is in a certain way. So this counts as unstructured data. And also audio is unstructured data. This can also be converted into numbers. Audio, you have video. So these are video, you can see as there's a lot of images, several images per frame. And then you have documents and PDFs, Word documents and other documents which have a text with a lot of information, but not stored it's not structured in a certain way. So this also is unstructured data. So you see there's a large variety for unstructured data. And when we are storing different types of data, we have different methods and different databases. So for structured data, you can store it using RDBMS. So this is Relational Database Management System. And it's stored in rows and columns. And this is based on the relational model. And in the relational model, each row is referred to as a tuple, and each column is referred to as an attribute. And relational model is based on mathematical model. So it's a mathematical set theory and predicate logic. So here you have tables. So the table structures, or it's also called in relational models, it's called relation. And the relation, it consists of tuples, which are the rows, and attributes for the columns. Okay, and these have strict schema definitions. And we have SQL to query the data. So SQL, and it has something called ACID compliance, which stands for atomicity, consistency, isolation, and durability. We'll come back to ACID later on, but what you need to know right now is that these are a set of properties that will ensure reliability and consistency throughout transactions in a database. So when you're making several transactions into a database, like adding several data instances, you need to make sure that it's done in a reliable way and it's consistent so that you have data consistency. Okay, so we have something called concurrency control, and it ensures that multiple transactions can be executed simultaneously without causing data inconsistencies. And we have semi-structured data, and here we have schema flexibility and NoSQL databases, so not only SQL. So this evolved first. They thought replace SQL, but it didn't. So SQL is still strong for structured data, but for semi-structured data, NoSQL databases works very well. So here you have MongoDB and you have DynamoDB. And another thing with a NoSQL is that they scale pretty well. And you have cloud object storage for structured data, and we'll come back to what that is when we go into unstructured data. For unstructured data, we have no predefined data model. We have object storage, and here, for example, we have Amazon S3, we have MinIO, and we have Azure Blob Storage. So it's storage on a cloud vendor. So this is basically the types of data. There could be a lot of new terminology here, so I suggest that you look them up and search for it and read about them. But we, in this course, will go into RDBMS. So this is the focus of data modeling in RDBMS, Relational Database Management System. So in that, which is based on the relational model. And for RDBMS, what is it? It's a way to organize data into tables or relations. And it's rows, and we have columns or attributes, right? And then we query with SQL, and it's based on a relational model, which it's managed data based on set theory and predicate logic. So this is what the relational model is based on. And it's developed from Codd, 1969, and he was a computer scientist, and he worked at IBM. So data, they're represented and grouped in relations. This is based on, it's a mathematical model, and what we refer to right now is rows, and the attributes are columns, and the relation is the table. So this is the terminology that is quite common now. So rows, columns, and tables, but you should know that it's based on the relational model. So we have for the rows, we have a relation for the table. And the advantages of RDBMS is that it has concurrency handling, as I told before, and it has data integrity and consistency. What this means is that data integrity, it's that the data is accurate and trustworthy, and data consistency, it ensures that the data remains correct across transactions. So this is very important. And then another advantage is that it's a very good way to organize the data. Yes, and with this, you have learned some basics about what type of data there are, different types of structures of the data, and how they are stored in different databases and different solutions. And then we've gone more into RDBMS, which is the Relational Database Management System. And inside of that, we've gone in a little bit on the relational model and some advantages of using RDBMS. So this is what the course will focus on. We will model the relational data. Yes, and thank you for watching this video. See you. Bye.